This is example 5.3.4 where I'm going to use Panagos example. This is the link, and you just need to Google Panagos Z transform inversion. Here is the example. Panagos has a very nice and comprehensive signal and systems channel as well as linear algebra. So we are going to do this example over here. Basically, we begin with a complicated Z transform and we are asked to find xn. The final xn looks like this. It has a causal part, an anti-causal part, and the causal part. So this x of n, or he used x of k, is a little bit different from what we have used before. In this particular case, because he has given us an additional constraint of the region of convergence, we have to be very careful when we perform inverse Z transform. We have to find the correct time domain signal, whether it is a causal sequence in this case, an anti-causal sequence in this case, and a causal sequence in this case. Let us find how to do this. So to begin, what we do is that we take this complicated expression over here and perform partial fraction expansion. And the partial fraction expansion of this is this over here. Notice that in the denominator of x of z, he already told you these are the three poles. So the only thing left for us to do is to express it in this manner and to find the numerator. To find the numerator, you have to perform this simplification, partial fraction expansion. You can follow Panagos video for it. The answer is 1, 2, and minus 2. So we can substitute 1 here, 2 here, and minus 2 here. You realize that when we have x of z in this form, it is almost immediately we can find the answer. So let us go to the Z transform table and find 1 over 1 minus half Z minus 1. You can use any Z transform table. Because we are now in the negative power of Z, I find this table. This is the entry we are looking for. 1 over 1 minus A Z minus 1 will be AN UN. Now remember, this is for a causal sequence. So Z must be greater than, in our example, it will be half. However, notice that we could have also chosen exactly the same sequence, but now it is Z is less than A. So 1 over 1 minus AZ minus 1 and 1 over 1 minus AZ minus 1, these two are the same. However, because of region of convergence, they have become different in the time domain representation. So the key idea is that you must select the correct one. So I take the first expression, 1 over 1 minus half Z minus 1, and I write it here. And if the input signal is causal, then the expression looks like this, half n un, with ROC Z greater than half. If the signal is anti-causal, is minus half to the power of n u minus n minus 1, and the ROC will be less than half. Now what are we given? That the ROC of the host signal must be ROC Z must be greater than 1, less than 2. So if I have chosen this signal ROC to be Z less than half, then there's no chance that I will get this ROC. If I get Z greater than half, then what happens is that it will still satisfy this constraint, because Z greater than half, here is Z greater than 1. So later on you will realize that there's an intersection of this region of convergence. So I am going to choose for the first expression 1 over 1 minus half Z minus 1 to be this signal. We can then do the second signal, which is 2 over 1 minus 2Z minus 1. So again, we are given a choice whether it will be anti-causal or causal. So I work out on the right hand side, 2 over 1 minus 2z minus 1 can be this causal sequence or this anti-causal sequence. For a causal sequence, it will be 2 to the power of n un with ROC z to be greater than 2. Anti-causal sequence is minus 2 to the power of n u minus n minus 1 with ROC less than 2. The requirement again is that the ROC is less than 2. So we must choose this guy. Alright, let's see Panagos' solution. So he also chose the second guy. I will not work through the third one, I'll just show you the answer. In the third one, he's going to choose a causal sequence. So remember that he have chosen whether it's causal or anti-causal because it is used to satisfy this constraint over here. Finally, the answer is x of, in this case you use index k, is equals to half k uk minus 2 times 2 to the power of k u minus k minus 1 minus 2 unit step. So this is the z transform of this guy. And to recap, once we have it in the simplified form, we can use the lookup table. The question is difficult because he has given us a ROC. Of course, to reach this step, you must have performed the partial fraction expansion correctly. Because this is the original form that is given to us. There's no lookup table for that. We have to use partial fraction expansion to get the coefficients correctly. And then we can solve by the lookup table. Thank you.